Today we're going to continue with 4.8, the extra practice on page 116 there. I want you to start on number 1, get it graphed, and then number 2, get it graphed. Okay, we're going to go through both of those together here in a minute. Don't worry about what it talks about the increasing or decreasing or odd or even yet. We'll deal with that in a while, but right now, find your end behavior, degree, zeros, your local max and mins, and your y-intercept, and plot those points and get them graphed. Work together there, 1 and 2. Okay, let's work at getting to a stopping point on number 1 and 2. If you haven't compared your work with the people around you, at least what you have done, let's get that taken care of right now. Okay? Okay. Well, let's see what we got. Number 1 and number 2. Let's focus in on number 1. Okay? Number 1, I've got those things now. Let me go ahead and list my degree. Degree is obviously third. And the end behavior, we list that, is down, up. Okay? So we've got all those pieces. Now, the x... Well, first, how many have that? Similar. Okay. Now, the directions actually say graph the function. Okay, we've got it. Identify the x-intercepts. We've got them. -1, 1.5, and 2.5. Okay. I did not show the factoring there, but I'm assuming that you can do that. That's a previous lesson. If that's an area where you struggled, you couldn't find those, then we need to talk. Okay. The points were the local maximums and local minimums. Got them. Okay? Where they occur. And then it goes into this other stuff that we haven't done yet. Okay? Determine the intervals. All right? And when we're talking about the intervals, I want to make sure that we hit this the right way so that there's not a bunch of confusion. Okay? Intervals where the function is increasing or decreasing. And then it talks about odd or even, or neither. And we'll talk about that. That's going to be the last piece. So let's go ahead and chop this function up. Okay? What we're going to do is we're going to cut it up based upon our maximum and minimums. So wherever there's a maximum or a minimum, you start at, from the far left, you start following your graph like you're cruising along on a path until you get to a max or a min. In this case, a maximum. Yes? I go to the 10th or the 100th. I just went to the 100th there. So what would you prefer? Well, for the graph here, the 10th would probably be fine. I mean, in terms of your scale, we're not, I mean, even the 10th, we're not getting too far, but I'd at least like out to the 10th. Okay? Don't go out to a whole number there. At least go out to the 10th. I've got the 100th, but that's because if I don't, then I have 0 here, right? And that's an issue. So I'm going to cruise along on this path until I get to a maximum, and then I'm going to stop. And that is going to be along this point right here. Notice how I'm tracing it, and all of a sudden my line's getting longer and longer and longer. Okay, that is my x value where I have a maximum. Okay, now you don't have to color it like that. I mean, it's okay just to say, okay, my graph crosses right there. That is a maximum. Okay, so I've cut my graph right there. And now I'm cruising along the path until I get to my minimum, and now I am chopping my graph again. You guys with me? We have formed 3 different parts to it because now from there we turn and we go up and we never come back down. Okay? Yes, Autumn. Okay, like I said, that'll be the last thing we do. Okay? So right now we're going to just go with this increasing or decreasing. So what I want you to do is I want you to focus on these 3 different regions. There's this region up to there. You have that middle region, and then you have this region out here. You know, I'm spending so much time on this because we kind of touched on this earlier in the year, and we really struggled with it. A lot of you missed it on what we did. Okay, so I hesitate to highlight this blue. I don't know if we'll see it all that well. You guys can. Okay. All right. So there you've got it. You've got your 3 different regions. Very good. All we have to do now is define those regions. Okay? So our graph is doing what right here? You're going up or down? It's up. It's increasing. So our graph is increasing. And now we're going to talk about where it's increasing. Okay, when is it increasing? Well, in terms of the x-axis, that's how you measure this. Okay, our graph is increasing until we get to negative 0.04. That's that maximum. So we're focusing right there. It's increasing until we get to negative 0.04. Now, mathematically, we write that as, well, it's increasing when x is smaller than 0.04. So all these values over here are smaller than, the reason we drew this line in is this is 0.04 right here. That is on the x-axis, that's 0.04. So if you think of it as a two-dimensional thing, okay, on the x-axis, negative 0.04, okay, and below, our graph is increasing. Okay, so from negative infinity until you get to negative 0.04, our graph is increasing. So when x is less than negative 0.04, our graph is increasing. At that point, our graph turns. Okay, and so we're using that horizontal scale. Okay, so if we kind of keep track up here, our graph is increasing over in this area. Okay, our graph turns and it starts falling until we get to, so in the blue region here, it's falling until we get to 2.04. So our graph is decreasing when x is between. Okay, so we may actually want to give ourselves room because it's going to be a compound. Okay, it starts at negative 0.04, and then it goes up to 2.04. Okay, so our graph is decreasing in that region right there. So if we think of it as a kind of our number line here, 2.04. Okay, we're decreasing in this area. All right, so this would be when x is greater than negative 0.04 but less than 2.04. Yes? That's what Walsh just asked.
Well, I mean, that's a little bit of a different question, just because, like, you said that if it was, like, you with the hundreds for the 0.04, because we couldn't just have 0. So, like, should we always go to the hundreds if it's...
It depends on the situation. Like, the reason I'm so specific here is because if I go to the 10th, I really don't have a value, right? Okay, so if I would prefer that I know that this is not exactly 2. Like, if I put 2 there, then I'm not really being as precise, and I'm kind of being misleading. Okay? Now, reality is when I graph that on this grid, the 0.04 is not showing up. Right? So I would prefer that you show, like if it's not exactly 2 or not exactly 0, I want to know that. I want to know that you know that. So if you have to go out to the 100th to show that, then do that. If you have to go out to the 10th to show that, then that's fine.
So should we just make a rule that you go to the first number after the decimal? The first non-zero number after the decimal?
No, I don't want to make a rule. I mean, just if I go to the first, yeah, if you need a rule, do that. Go to the first non-zero number after the decimal. Okay? In science, you guys start talking about significant figures and stuff. Have you guys done that yet? Yeah. Okay. Hey, you know, right? I don't want to get that intense on it. I just want you to know that when you report this, don't report it as 2 because it's not exactly 2. Yeah.
When we calculate the min and max on the calculator, sometimes it's a number really close to 0 and they represent it as like 0.12 to the e or 2.
Yeah, then we'll call that 0.
Okay.
Yeah. If it's scientific notation on your calculator, then we're calling it 0. Okay, now from there, what's happening? Good. We start increasing again. So we increase again when x is bigger than 2.04. So if you think of it on your number line again, it's increasing. So really, you could use a number line approach on this. Say, hey, my graph, using my x-axis as a measuring stick, it's increasing prior to 0.04, negative 0.04. It's decreasing in between negative 0.04 and 2.04, and then it's increasing again. So you could write this. You could say, okay, well, this region right here is x is less than negative 0.04. This region right here is a compound inequality. We've talked it like if we were doing shading. That's a compound inequality we will come back to, and then it's increasing again when x is greater than 2.04. That compound piece, this chunk right in here, we can kind of take out and say, well, that's in between negative 0.04 and 2.04. So that's written out like that. It's another way to think about it. Okay? Think we got it?
So is the test just going to be like 3 graphs?
Okay, don't ask any more questions like that for now. We will talk about test and quiz right now. Right now, guys, I really am concerned about this because you guys had a quiz on it earlier in the year. You really struggled with this. This was a huge concept that you struggled on, chopping apart a graph. So if it helps to color it out, write it in this form. I'm trying to hit as many different formats as I can right now to help out. Megan.
So when we wrote them separately, increasing, decreasing, and then increasing again, would you prefer us to write it like that, or you want us to write it like you did up above, where they're all in one line?
You could write it either way. Whatever's going to work for you. On your test, I'm going to probably give you 3 lines or a place for you to write increasing and then decreasing. Okay? All right. Number 2. I want you to break it apart now. Increasing, decreasing. We got now. Going to be a few more sections on this one, right? You have more max and mins. Okay, what's happening in the yellow sections there? Good, it's decreasing. Okay. In the pink areas we have increasing. All right. Feels cool to color inside and outside of the lines all at once. Feel pretty special. All right. So we're increasing. I'm going to list all my decreasing in one spot now. Okay. So I'm decreasing from here to here. So when x is at infinity, it goes all the way, it decreases until I get to negative 3.34. That becomes a minimum. Okay, so, or in this case, if you wanted to write negative 3.3, that would be just fine. Okay? So it decreases when x is less than negative 3.3. And it also decreases when x is less than, so we're cruising along, we get to here and we start decreasing again. So this maximum was at negative 0.22. So from negative 0.22, it starts decreasing until we get to that point, which is a minimum at 1.68. So when x is less than or greater than negative 0.22 and less than 1.68, it is increasing, or decreasing, excuse me. Okay, increasing. Any questions on the decreasing? So from this point, at the negative 3.3, we start going upward again. So we're at negative 3.3. We go up until we get to the negative negative 0.22. Okay, so when x is greater than that, but less than that. Good? Yes, signs are flipped. Good job. All right. Good? All right. And then from here, we're good until we get to here, and then we start increasing again. So at 1.68, when x is bigger than 1.68, we start increasing. Just double check your signs, and usually the best way to do that is at the back part right here. When you get to there, say, okay, am I pointing in the right direction? Yep, I was. Or I wasn't, but you were. So those of you who got it there. All right. Yes, Kendall. What do you guys think? 1.7 okay? Yes. I didn't realize going to the 100th today was going to cause so much discussion in class. Next time I might go to the 10,000 and see if you guys really start freaking out. Holy moly. All right. No. Everyone rate themselves 1 to 5. Your understanding there. Okay. Now, what's the other piece we haven't covered? Odd and even, or neither. Now, I'm going to show you the other graphs here, and we're not going to graph all these, but I will tell you that both graphs we graphed are neither. Both pictures we graphed are neither. The next two pictures, this one's neither, that one's odd. Okay? Now, I want you to study that odd one, and this one gives you 4 different ones. It gives you an odd, it gives you an even, and it gives you a neither, and a neither. When is a graph odd? When is it even? When is it neither? Okay? In picture form. Study the picture. Don't worry about anything else. Just study the picture. What makes it even? Do you think makes it even? What makes it odd? What makes it neither? Talk to your group. Hey, can I have your attention back up here? Any ideas? When is it even or odd? Yes, Emily.
On the even one, the minimums are like the same.
They're the same? Okay.
Compared to ours, there was one at 138 and
Good. So the minimums are the same. I like that. You have to add?
On the odd one, wait. I had it.
Rory? Okay, they're opposites, the minimums, okay? Here, maybe if we look at it upside down, that could help too. That one's odd. Hold on, did anything change there? Hold on. Hold on. Hold on. Let's see. What's an odd have to have? Yes. Not congruent sides. Hold on, let me spin it about the origin. It is, what is that called? Rotational symmetry. You can rotate. Hey, is that what you're saying, Dallas? I can't hear you. I thought everything's bigger in Texas. I couldn't even hear you. You got to use that big voice. Okay. Hey, look. Rotational symmetry. An odd function will have rotational symmetry about the origin. Now, that only helps if you've graphed it, which you don't want to have to graph every one to figure that out. An even function has, what's this? It has line symmetry. It's a reflection. Okay, you can fold it. So like Emily said, these points are the same because they reflect about the y-axis. Okay? So in a picture form, hey, if it reflects about the y-axis, it's even. It's an even function. If it has rotational symmetry, 180-degree rotational symmetry about the origin, it's odd. Okay? If it doesn't have either of those, then it's neither. So notice this one doesn't go through the origin. You're like, well, what? You can turn that, it looks the same. Well, it kind of looks the same. This point right here is positive now, and before it was negative. Okay? That's not rotational. This one isn't rotating about the origin. We understand that? Okay.
Wait, but the number 5, that doesn't go through the origin either.
Wait, you're right, but it's an even. It's just a fold on that one. Yeah? Yeah.
In order for it to be odd, does it have to be to an odd degree?
Well, we're going to kind of see that here in a minute. I'm going to let you make those conclusions. Okay? So, let's say you don't have a picture and you want to figure it out. The first thing you need to do, let's say we have this function right here. So, number 4, just on your page there, just write, hey, I'm going to figure out if it's odd or even. The way you do it, the way you figure out if it's odd or even every single time is you take and do that. Now, that's becoming a theme. We've talked about that a lot this chapter, right? What does that mean? We plug negative x in for x. So if it's odd, is it going to change it? Yes, it becomes negative x cubed. This is going to become plus 2x. So those of you who are like, how did he do that? Remember, that's where you are plugging negative x in for x. So you're saying negative x to the third power plus, or excuse me, minus 2 times negative x. It becomes this. Okay? Everyone with me? If this and that are equal, then it's an odd function. If that and that, what's this mean? Yeah, you just flip all your signs, right? Your original sign. So if I flip this sign, I get negative x cubed. If I flip that, I get positive 2x. They're the same. That's an odd function. So if k of negative x equals negative k of x, then it's odd. And that's actually in your book. Not explained quite like that, but that's what it means. It's even easier if you want to find out if it's even. Okay? It's even easier. With even, hey, we do the exact same thing. Stay with me. We do the exact same thing. Does this change? Negative times negative times negative times negative? No. Does this change? No, because they're even. Okay? That becomes negative 29x squared, and that stays the same. If it's even, write down what the statement is. If it's even, f of negative x has to equal f of x. If that's true, then it's even. Okay? So you should always kind of be skeptical. I mean, I don't mean be rude, to your professor or your teacher. But, when I've told you this one right here, number 3 is neither, I would expect the curious mind would go, well, is he lying to me? I mean, maybe he doesn't. Maybe he made a mistake. And we put in negative. It should be you should be getting really fast at doing that. That changes. Okay, this one stays the same. That one changes. And that one stays the same because it doesn't have an x. That obviously does not equal that, right? And I guess we'd be doing h of negative x. Okay? And if we flipped all the signs to get negative h of x, that would become negative x cubed plus x squared plus 13x plus 3. Hey, those aren't the same either. Therefore, this is neither. If neither are true, then there. And that's nice when you don't have to graph it to figure that out. Right? Okay. I meant to be done about 5 minutes ago. But there you go. Your assignment is the back of 4.8 now. Okay? Which is not that side, it's that side. Now please note, on these graphs, you are doing all of that stuff. All that stuff. You can do it.